All right. Hello. Hi. Thank you, Xiaolu. Let me share my screen. All right. So can everybody see that?
Yep.
Okay. All right. Thank you. Yeah. So hello. It's a pleasure to be the first speaker to to present in this meetup. Sorry for my background. I'm in a hotel in Tokyo, so it's rather cramped. So yeah. So the topic I want to talk about is WebAssembly as a container runtime. I think it's highly relevant to openEuler and also to Quasar because um, you know um, um, as we'll discuss in a minute, one of the goals is to bring a variety of different container formats into the cloud native ecosystem, right? So WebAssembly is being one of the first technologies that are being supported um, on on those technology stacks. So yes, start. So perhaps I think I have 20 minutes also. So I'll start with a very brief introduction of what WebAssembly is. It's a sometimes it's hard to explain what WebAssembly is and how it's related to containers because the name is very misleading. It's not web and not assembly, right? So it's however, when it was started, it was about running C, C++ compiled applications on the web, meaning that you want to run, so the idea, um, this problem has always existed. That's on the web, we have HTML, CSS, and JavaScript. Those are all fairly slow technologies, but people want to play games in the browser. So they want to compile C, C++ applications or Rust or Go applications and have them run in the browser. However, the challenge for that really is that the browser cannot run native code because it has all kinds of security issues because those code are just downloaded from internet. If you just let them run in the browser, it's gonna cause harm to the user because it crashes the browser or steal data, whatever. So what they do is that I think starting from almost 25 years ago when Java first came along, it was the same idea is that I have some kind of virtual machine in the browser that runs assembly language code. So C, C++, or other language, or Java for that matter, can be compiled into a bytecode format that is, look like assembly language. And then you can have high performance applications running in a sandbox inside the browser. So that's the whole idea. That's how this thing gets started, right? So WebAssembly actually started in 2010, when Alan Zakai, when he's at Google now, at the time, I think he's at Mozilla. And so he started experimenting with high performance JavaScript. And then fast forward to 2019, right before the pandemic, WebAssembly becomes the fourth language for the web, meaning it's the fourth official recognized standard in W3C. So W3C recognizes HTML, CSS, JavaScript, and WebAssembly, right? So it has gone through the whole process of providing a secure and high performance sandbox for the browser. Okay, but one interesting thing about it is if you provide um, a sandbox or isolation format for the browser, you can use it on the server too, right? Because that's essentially how Java on the server gets started. That's also how JavaScript on the server, Node.js got started. Is that you have a technology that can reliably and securely run in the browser. And the browser is a very hostile and a very unpredictable environment. You will be able to run the same technology on the server as well and have all the benefits of what we today know as container runtime, essentially security and isolation sandbox, right? So as you can see, from 2019, right before the pandemic, around the time WebAssembly was standardized on about W3C in the browser, it has become, people are working on providing systems, what we call WASI, system interface. If you think about WebAssembly in the browser, it's mostly interact with JavaScript, so it doesn't need to know the things like file system or networking or underlying CPU and GPU, things like that, because JavaScript provide all those functionalities to the WebAssembly runtime. However, if you want to run it on the server, it has to run directly on top of the operating system. So it needs things like networking access, file system, environmental variables, and things like that. So that's what WASI has been born. WASI essentially is a POSIX standard for WebAssembly so that it can interface with the operating system underneath it. And once you have that, it lays the foundation of running WebAssembly really as a container, as being managed by Kubernetes at the same level as, say, Linux container, Docker container, and things like that. So fast forward, we went through the whole pandemic. I, there's lots of discussions and conferences, and then by the end of 2022, CNCF Cloud Native Computing Foundation has released a survey that has a very strong statement. It said containers are the new normal. Container has become the normal. WebAssembly is the future. Is that meaning on the adoption curve, the container has reached the mainstream stage, and WebAssembly is reaching the early adopter stage. So if we look at this survey, which I find it's very interesting, because it's the official annual survey, it's the official survey CNCF does for, I think CNCF has over 1,000 member companies that are paying at least $5,000 a year, and a couple hundred projects that are at different stage of sandboxing and incubation. And so it covers a large swath of cloud computing users and developers. And this whole annual survey of CNCF has only one key findings. It doesn't have multiple key findings. There's only one. Containers is normal and WebAssembly is future. It's find that 37% of the users are already using WebAssembly in the cloud native environment. I don't think it's necessarily using it as a container at the moment. A lot of those use cases are using it as a extension mechanism. But we're going to focus on the container use case for the rest of this talk. And you can see, some of the popular WebAssembly runtimes. WasmEdge has become the most popular one on the server side. I think primarily because this is the CNCF survey, and WasmEdge is a CNCF project. So like many technology before that, especially Java and JavaScript, WebAssembly get massive success in the browser and become the standard. And then it become obvious. The same characteristics that has made it successful in the browser can also make it successful on the server. So when we talk about WebAssembly on the server or WebAssembly as a container, we have to go back to 2018, end of 2018, when Solomon Hykes is I think it's a well-known person. It's a founder of Docker. It's the original CTO of Docker, right? He tweeted at the time, if WASM, WebAssembly plus WASI, WebAssembly system interface, what I just talked about, the POSIX interface for WebAssembly, existed in 2008, we wouldn't have needed to create Docker. Docker would not have existed, okay? That's how important it is. WebAssembly on the server is the future of computing. He said that almost 4 years ago, right? That's as you can imagine, when he said that, there's an uproar in the community. There's lots of people who's very invested in, say, Docker and Linux container. They will come out and say, is it really true? That's Linux container would not be important in the future anymore. So most people missed the tweet that he had follow up. So he said, well, what WASM replace Docker? No. But imagine a future where Docker runs Linux containers, Windows containers, and WASM containers side by side. Over the time, WASM might become the most popular container type. So what he visions is a container runtime that runs different type of containers, which is exactly what Quasar is, right? So I think a couple of years later, fast forward to 2023, the ecosystem has finally matured to a point where where we need Linux container, but we also need other types of containers. WASM container being one of them, perhaps even the most important one of them. So this is, I think very, a very interesting prediction that the founder of Docker himself has made over 5 years ago, right? So that's a little detour. So well, this is WasmEdge runtime is one of the WebAssembly runtimes out there, and this is our project. This is also one of the projects that's integrated with Quasar. So it's we position it as a cloud native WebAssembly runtime, meaning that a lot of the WebAssembly runtimes in the past has its roots in the browser. So they are focused on interaction with JavaScript and the browser environment. And WasmEdge started in 2019 from the get-go. It was to support WASI. It will support running directly on top of operating system. We are not integrated in the browser, in the browser in any way. Although now we are integrated into browser because there's new generation of browsers are looking for lightweight and high performance WebAssembly runtimes. Some of them use WasmEdge, but the design principle of WasmEdge is really to do a cloud native WebAssembly runtime. So we're talking about WebAssembly may be the next container format. It may replace Docker, it may not, that may supplement Docker, but why? It's what is the problem it's trying to solve, right? That's people are using a Linux container as an isolation format, or virtual machine as an isolation format for a very long time. What are the problems that has recently emerged or has always been there that that requires WebAssembly to solve, right? So I think it boils down to mostly performance and footprint and security, right? So compared with a Linux container image, WebAssembly image that does similar things. We are talking about things like AI inference. So a lot of people use WebImage to do AI inference, image recognition, and things like that. If you do that in a Linux container with Python and with PyTorch and with the whole stack of things, the container image could easily be 1 GB, 2 GB. We have all seen that. That's which makes it really hard to run it on the edge, on the home router, on the camera, things like that. But with Wasm Edge plus PyTorch, Wasm Edge plus TensorFlow, you can get the whole image size down to like 40 megabytes, and or even less, right? So it's essentially, that's so for most smaller models, that's a very compelling story to have something that is much smaller, okay? And it's much faster startup time. That's there's many different benchmarks, but some of the benchmarks that show it depends on what you are comparing to. If you are comparing to, say, AWS Lambda with a Java runtime, that startup time could be in the seconds. It's 5 seconds, 6 seconds. That's easy, right? That's but WebAssembly startup is typically in milliseconds, under 10 milliseconds. So you could see, say, 1,000 times faster performance improvements. At runtime, it also has a large amount of performance improvements over, say, something like Python or or JavaScript, right? And it's secure by default, and meaning that's by default it doesn't have access to any of the operating system features. You have to specifically declare what operating system features that you want to give it access to, and because it doesn't have operating system inside the runtime, so it has a very small attack surface. It's impossible to say, I forgot to turn off the web server inside the container image because there's no web server in the container image. There's no Apache or Nginx in there. It's just a WebAssembly runtime. So it's a very small attack surface. And it's completely portable. Unlike Linux container, the container image depends on the underlying CPU architecture or even GPU architecture. Say, if I tell you, do a Docker image for NVIDIA GPU. That's a major effort. Take multiple days. But for WebAssembly, it's because it runs in the browser, so it abstracts away all the underlying hardware features, and so you can have access to GPU, you can have access to different type of CPUs, RISC-V. You can also, and it's also operating system agnostic. We have made it running on OpenHarmony and real-time operating system as well. So there's a lot of things that we made it, um, you know, um, it can become a platform independent runtime, and it plays well with um, 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 uh, service orchestration framework. That's where Quasar comes into play, right? Which we're going to talk about in a minute. So we have published papers on IEEE about the performance characteristics of WebAssembly, but this is a performance study that's recently, I think it's last week, done by ARM. So developers uh, at ARM has compared WebAssembly with, I would say, a naked container, meaning that a container that doesn't contain any operating system. So basically, they have a simple application that compiled WebAssembly. The application itself is written in Rust. It can compile to WebAssembly and it compile into a native format for ARM. And then ARM runs it in a Scratch container, so it doesn't have operating system in the container, which is the fastest way possible to run the container, right? So if you look at the startup with the size, the boot up time and the runtime memory use, and WebAssembly is a clear winner, even with the most slimmed down and most because if you don't have operating system in the container become utterly unportable. It heavily depends on what libraries the underlying operating system going to provide, right? So WebAssembly retains its feature of security and portability, but still wins at performance, right? So this is I find it's interesting because it's done by a completely impartial third party, which is ARM, right? So there's another way to look at it. The benefit of WebAssembly. Those are the two tweets that we sent out that has generated some interesting community feedback. And by the way, the WebAssembly Twitter account is not a huge account. It's only like 1,000 followers, but you can see both of those tweets have over 10,000 views. Meaning that there are, a lot of people on Twitter shared them and it were widely seen. So, the first one is that we demonstrated a complete Redis application, a Redis client that runs in WebAssembly inside, the Docker desktop. The entire application size is 700 kilobytes. Okay, so we are talking about a complete microservice or a cloud native type of application that is measured in kilobytes. If we are doing this, say, we even have a slim Ubuntu container plus the Redis library, plus the whatever the language framework that is required to run Redis library, like say Python Redis library or JavaScript Redis library, you can easily run into tens of megabytes or even hundreds of megabytes, right? So people find this very surprising. That's you can have a completely functional application that has a clear comparison to a Linux container application for such a small size, right? So on the right side, it's a very similar to it, but instead of doing Redis, we're doing PostgreSQL, right? So with PostgreSQL, the application that does the create, read, update, and delete is only 800 kilobytes, 0.8 megabytes. So instead, if you look at the official Docker distribution of, say, application that has a Postgres driver in it, right? That's you are looking at again tens of megabytes in here. So the resource saving and space saving is very significant when you use WebAssembly as a runtime, as opposed to a traditional container runtime, a Linux runtime. So, but you know, just to have the runtime is not enough, because the cloud native ecosystem has evolved in such a way that a lot of those depends on orchestration and container management. So the container runtime has to work well with all the container management tools. And at WebAssembly, we invested in a lot of time to do that. So on the panel at left is the work that we have done with Red Hat. So WebAssembly is now official package in Red Hat Enterprise Linux. So we are in Real 8 and Real 8 and Real 9. And so it's part of the OpenShift ecosystem. And what that does is that at the OCI content runtime level, at C-RUN level, and so in OpenShift, they can support C-RUN and Yuki. So both C-RUN and Yuki are configured to support WebAssembly, meaning that when they see a container image, it would automatically decide whether it's a WebAssembly image or it's a regular Linux container image. If it's a WebAssembly image, it start WebAssembly to run it, right? So it does a bifurcation, when it sees the container image, right, at the C-RUN level. And then the work we did with Microsoft is to integrate as container D level. So it's another container D shim called runwazi. And so that's work we worked with Microsoft Azure and Docker Desktop. They go this route. So instead of go all the way to the OCI runtime and replace C-RUN, they are making the judgment of whether this is a Linux container or it's a WebAssembly container at the container D level. So at the container D, they can go to use WASM to execute the WebAssembly image, and then use the runc to execute the Linux container image. So both are good. It just happens at different level of abstraction in the Kubernetes stack, right? So that leads us to Quasar. That's with Quasar we have now Quasar, we have now a perhaps more interesting approach. This approach is similar to the container D runwazi approach that we described, right? That's essentially the Microsoft and Docker approach. And however, it's not just the container D shim. It's leverage more of the container D APIs like the Sandbox API and things like that. So it's provide a tighter integration. So we really look forward to make WASM the first class citizen in the Quasar container D ecosystem. So let me see. Yeah. So I don't think I have a lot of time, but I do want to touch upon um, some limitations, because I think that's also important, because if you look at Solomon Hayek's first tweet, he basically said, it's possible WebAssembly going to replace Linux containers, because he said we wouldn't have done Docker, if this thing existed, right? But then he wrote it back to say, oh, maybe it's a coexisting ecosystem. That's actually, we believe in the second statement, so although we are WASM, runtime company, we believe WASM would not replace containers because the reason is also very simple, is that because it doesn't really provide a general operating system environment. It doesn't fulfill Docker's or Linux containers promise of what runs on my computer going to run on your computer as well, because I can just ship the Docker container, with my application, right? In WebAssembly, because it's a new bytecode format, it doesn't have an operating system there. That's why it is fast, it is secure, and it's lightweight. And in order to have all those features, it needs its own byte format, which also means you have to recompile your application. Sometimes you need to rewrite your applications for this particular use case. So WebAssembly is more suited for, say, new applications or applications that really require performance, or application that needs to be run on the edge. That's also where the name WASM Edge come from, right? It's that there's places where, say, Linux container is too big or difficult to fit. That's why we need, I think those are the sweet spots of, WebAssembly applications. That's so what are those? One, of course, is microservices, right? Today, most microservices are written in languages like Go or Java, some are Rust, and they're all packaged in Linux containers. And multiple services can exist in the same pod, managed by Kubernetes, things like that. So, but there's lots of microservices use cases where, say, log processing, and as microservices become more and more finely grained, it's this pattern has become more and more heavy, right? Say, let's use the example. It's common microservice is to process logs. Traditionally you have the ELK framework, right? Elasticsearch, Logstash, and okay, that's those are three JVMs, and three JVM packaged in its Docker Linux container, which contains its own operating system. And to do what? Just to do log processing, right? With WASM Edge, you can have one container that has that's a simple application written in Rust and wrapped around in a WASM Edge container and runs in the same Kubernetes cluster as the entire ERK stack, which takes like 1% of the size and has much higher throughput, to process, say, MySQL bin logs. Forward MySQL logs to Kafka, forward MySQL logs to Red Panda, use cases like that. And then streaming data functions, meaning that's I think more and more so, the data processing frameworks like YOMO, EMQ, Kafka, Red Panda, those are all our integration partners. They want to build their own processing into their messaging frameworks. However, the processing functions are provided by third-party developers. So you would need to provide isolation for them, right? So that's um, another good use case of WebAssembly. So serverless functions for SaaS is another one. As SaaS become more and more complex, a lot of times people, instead of interacting with SaaS using API from outside, people needs to embed third-party code directly into SaaS. One of the great examples that is shown is ChatGPT, right? ChatGPT has an API, OpenAI has an API, but does a lot of people use that API? Some people do. But by far the most popular use case is plugin. Is I write some application and put the code into and have some of them, a part of my code runs inside the ChatGPT platform. In order for that to happen, I need some kind of isolation, need some kind of container, container runtime, and in this case as well, a lightweight container or lightweight isolation sandbox would be able to play a major role here. So yeah, that's I think that's my 20 minutes, and thank you so much. And um, um, as I mentioned, Quasar is really the orchestration and runtime framework that the industry has been looking for quite some time. That allows us to mix and match different workloads in their own optimized container runtimes. And I really look forward to collaborating further in the open source community with Quasar and openEuler. Thank you.
Okay, thank you, Michael. It's very, very exciting presentation. Okay, thank you. It's happy to see you again in openEuler. Yeah, It's
Yeah.
been 2 years. Yeah.
Yeah.
2 years ago is the first time you share your resume to openEuler in our Cloud Native second meeting. Yeah. Could you please update us some key achievements on resume for the last 2 years? Okay.
Yeah. So I think one of the big things about Wasm Edge is it's now integrated into many more places, right? So we're now in Docker Desktop. So people say, "Oh, I don't know if I have Wasm Edge installed on my computer." I say, "You are developing cloud native application. High likelihood you already have, because we are bundled with Docker Desktop." So if you have Docker, you probably do. That's allows to use the entire Docker tooling, including Docker Compose and things like that to manage Wasm Edge containers side by side with Docker with Linux containers. So we have several examples where we have we have a three-tier microservices. There's a web server. There's one which acts as a proxy. There's a database server, which is a MySQL, something like that. Then the business logic sits in the middle. So the business logic used to be in a container written in Java, application written in Java or Python, but put it in the Linux container. But now we can replace the whole stack um, um, with a Wasm Edge runtime. That requires us to build a lot of functionalities to Wasm Edge. So, for instance, you need to be able to connect to the database in a secure fashion. It needs to do that in a non-blocking, asynchronous way. So there's lots of underlying networking and infrastructure work that we have to do to make WebAssembly fit for this purpose. And then along the same line, we have expanded WebAssembly to do AI inference, which is perhaps one of our major use cases at the moment. People have PyTorch or TensorFlow models, but they don't want to use Python to do the model serving or the inference because it's too heavy. So you use WebAssembly for that. We are even expanding to say large language models like Llama, Alpaca. Those are languages that we are currently experimenting to see if we can use WebAssembly to do lightweight inference on them as well. So that would produce significant savings in the data center. But then again, I think WebAssembly as a whole is also evolving very fast. Perhaps the most important next step for WebAssembly is the component model, right? The component model really is um, um, it's try to componentize all the libraries and the functions around WebAssembly so that they can be managed properly in its own repository tree and be able to generate all the application interfaces from those libraries, right? So there's a lot of excitement that has been going on with server-side WebAssembly, and yeah, that's if you're interested, that's I'm we'd love to talk to you offline or come to our GitHub repository and see some of
Yeah.
our latest talks. Yeah.